We're going to do a second video on some difference in double angle identities. We're going to do one more problem like the problem we did at the end of the last video. So sine of A is 3/7 and cosine is positive, so that puts us in the first quadrant. So 3 and 7. Then in order to find the x distance here, I'm going to use the Pythagorean theorem. So it's 3 squared plus x squared equals 7 squared. So that's 49 minus 9. So x equals the square root of 40, which I can reduce to be 2 times the square root of 10. So that's A. Now B, the secant of B, is 25/7. So if that's the case, then sine being 0, cosine and secant are positive in the fourth quadrant when other things are negative. So secant being 25/7 means that's a 7, 24, 25 triangle. Tangent of A minus B, so that's tan same tan. So tangent of A minus tangent of B over 1 oppo tan tan. So now I just sub things in. So the tangent of A, in this case, is going to be 3 over 2 root 10. The tangent of B is going to be, I should have made that negative for ease of understanding. Tangent of B is negative 24/7 divided by 1 oppo tan tan. So I already know the tangents here. Now this is kind of ugly, but we'll make do. So I have to get a common denominator up here. So I'm going to multiply the top and bottom of the first one by 7. So I have 21 over 14 root 10. And then plus, I have to multiply the top and bottom by 2 root 10. So that's going to be another 14 root 10 in the denominator. And then I end up with 48 root 10 all over the denominator, which is 1 minus, and the reason it becomes a minus is we have that negative 24, minus 72 over 14 root 10. Now, in order to make this as simple as possible, I'm going to rewrite this 1 as 14 root 10 over 14 root 10. Now notice that everything has a common denominator, and now I can simplify this. So I know that I'm running out of room, but hopefully you're not. So we end up with 21 plus 48 root 10 over 14 root 10 minus 72. And I'm now going to erase everything over here. If you need it again, then rewind the video or something. But we're almost done. We just have to, I mean, these numbers are nasty. I made up the numbers, and we wouldn't do this to you on a no calculator test. But these numbers are kind of big, but I also have a radical in the denominator. So I have to multiply by the conjugate of the denominator. So 14 root 10 plus 72 gets multiplied by the top and bottom. And yeah, it's pretty nasty. 14 times 14 is 196, and root 10 times root 10 is 10. So that becomes 1,960. And then the middle terms cancel. And I have 72 times 72. That ends up being 5,184. I promise you we won't do those nasty numbers to you on a test. So we have the denominator is negative 3224. Then the numerator becomes 21 times 14 root 10. So that's 294 root 10. 21 times 72 is 1512. 48 root 10 times 72, that's not very fun. 3456 root 10, and then 48 root 10 times 14 root 10 becomes 672 times 10, which is 6720. So I now add all these things up, and I get 8232 plus 3750 root 10. And that, my friends, is not very pretty to look at. But that is tangent of A minus tangent of B. Okay, secant of A plus B, the easiest way to do that, and if you need to go back and look at that, rewind the video. Secant of A plus B is going to be cosine of A plus B, and then take the reciprocal of that when you're done. So cosine of A plus B, cosine coalition changes the sign. So the cosine of A is going to be 2 root 10 over 7. The cosine of B is 7/25. The sine of A is 3/7. And the sine of B is negative 24/25. So I have 14 root 10 plus 72 over 25 times 7, which is 175. And then since I'm finding secant, I have to flip this. So it's 175 over 14 root 10 plus 72. So since it is since there's a radical in the denominator, I have to multiply by the FFU, which again is not going to be very fun because I have 14 root 10 times 72. So I end up with 1960 minus 5184 as my denominator because the middle terms cancel out. And then the numerator ends up being 2450 root 10 minus 12,600. So 2450 root 10 minus 12,600 divided by 1960 over 5184, or minus 5184, gives me negative 3224. And actually, I could reduce that more because everything is even, but in the interest of time, I'm not going to do that. So that's something that you guys can actually end up doing. Sine of 2a, again, if you need all that, rewind the video. Now, sine of 2a, that's 2 sine a cosine a. This really is going to be way easier than the other ones. So 2 times 3/7 times 2 root 10 over 7. So I end up with 12 root 10 over 49. And thankfully that one doesn't reduce. Okay, now we're going to verify the identities. Sine of 2x equals 2 tangent x over 1 plus tangent squared x. I'm going to end up, I'm probably going to use the right-hand side because it just looks a little bit more complicated. So 2 tangent x divided by, well, if I look at this, 1 plus tangent squared, I know that's an identity, and that identity is secant squared. So now I have secant squared in the denominator. I know that secant squared is the reciprocal of cosine squared. So I'm going to write this as 2 cosine squared times tangent. And then I also know that tangent is sine over cosine. So I have 2 cosine squared times sine over cosine. And that ends up, one of the cosines cancel, so I have 2 cosine x sine x. I'm going to use the commutative property of multiplication to get 2 sine x cosine x. And I know that 2 sine cosine x is sine of 2x. So because I know that's true, I'm done. So I can now use sum and difference and double angle identities in order to verify identities. So now let's take a look at number 2. Number 2, I'm going to use the right-hand side because I think tangent x plus tangent y looks a little bit complicated to deal with. And the right-hand side is more complicated. I just didn't know how I was going to take the left side and turn it into the right side. So what I'm going to do is use the sum identity for sine. So separate signs with the same sign. Sine x cosine y plus sine y cosine x. That's all divided by cosine x cosine y. And now I'm going to rewrite it as sine x cosine y over cosine x cosine y plus sine y cosine x over cosine x cosine y. Notice that the cosine y's can cancel in the first one, and the cosine x's can cancel in the second one. So I end up with sine x over cosine x, plus sine y over cosine y. And that looks a whole lot like tangent x plus tangent y, which is exactly what I was trying to get and what it looked like on the left-hand side.